Okay. Testing online. Can you hear me? Testing, testing. Testing. Testing, testing. Hello, hello, hello. Testing. Online, online. Can you hear me? Testing. Online, online, online. Can you hear me? Okay, cool, great. Thank you. Perfect. Oh, good. Okay. Alrighty, so today's lecture should be quite relaxing, like not very hard, although quite important, but I think it's pretty straightforward, not very challenging. And I will hope to finish not in a rush, but like early today, so we can give some time back to you. Maybe you can work on your project, work on your other assignments. Yeah, so welcome to week 5. Is it a busy week for everyone? Yeah. Oh, really? Do you have any assignments due this week? Oh, good luck. Yeah, the good news is for this course, for 9820, it's not very challenging week this week. The content this week is pretty easy. Okay, cool, amazing. So today, so this course is called project management, right? Software project management. But we talk a lot, so far we talk a lot about agile project management, right? So everyone on the team makes a very important role to manage the project together. But there's, like, other than the general team members, there's also a role called manager, right? So if you go to industry, if you work on an industry project, there will be a manager. Or if you work on a startup, there will be like founder, co-founder who manage the project. So today's first lecture topic will be focusing on the role of that manager. So if you go to industry, you get a job of like a manager. Or if you start your own startup, you are managing the project as a leader. What should you do, or what can you do to make the project agile, bring value to the customer, efficient, adaptable to like changes? Okay, cool. So let's start with the story. So now you are a manager of an agile software project, and you check in with your group maybe weekly or bi-weekly, and then ask them for demos. They show you what they have done, maybe some new stories delivered, some new features. Everything seems okay. However, as time goes, you notice that there are some bugs, more and more bugs, right? Although the features are delivered to you, but you get more and more bugs. And when you deploy the project to the end users, more and more problems arise. Right? What should you do in that case? What can you do? You are the manager now. Okay? But your project is delivering new feature. Everything like at beginning looks good, but like gradually you're starting to see the software project becoming more and more buggy, like more and more defects. More and more issues came to you. What should you do? Like, how can you help the team, the project getting better? Sorry? Have a like tracking system? Yep. Yeah, so what kind of information would you like to track? performance, yeah, like metrics. Okay, cool. So that's a very common direction. Like a lot of managers do that. So can you be a little bit more specific? Like what would you do to help the team's success? Huh? Code reviews. Oh, that sounds really good. What else? Okay, so this manager decided to add some more code reviews as well as more metrics. For example, the problem that they had earlier was like growing number of bugs, although the stories are delivered, right? So they want to see whether there's enough number of tests, whether all the features are tested thoroughly, right? Because there are bugs, like, right, we can add more tests, add more metrics on the test. And then this is the decision made by the manager. Okay, so a few weeks passed. You see, wow, almost all of the features are covered by tests now. Like you saw a large number of tests now. However, you got another issue. Although there are more tests, your software is still being buggy, right? There's still a lot of bugs. And tests is, because the number of tests grow a lot, the test also becomes really slow, right? Why is that? What can you do next? This is very common. Like now you're starting a startup, right? Software startup, and now you're facing this issue. How can you solve it? Maybe that's because you are asking for those numbers, like show me how many tests you've got. Show me if you have covered all your functions with the test. This was what you asked for, right? So the team now is driven by that metrics and starting to add a lot of trivial tests. And their goal is to make sure that every line of the code is covered by a test, rather than having the goal of like the software project being stable, safe, everything works as intended. So their goal changed, shifted, because of the direction of the manager. Right? So this is very common. So how can we balance that? How can we address this issue? Like at the beginning, there's no metric, right? And then we got a lot of bugs. Later on, we add metrics. Still a lot of bugs. Like we are not solving the fundamental issue. Okay, so this is what we are going to talk about today. We are talking about the role of managers and how to manage software projects with the example of coverage report as the metric. This is an example. Okay, cool. So to summarize the story that we just talked about, so managers need to know whether teams are working efficiently and how to help them succeed, like where's the issue, how to help them succeed. Reports like metrics such as coverage report are a great example of how metrics can help or harm depending on how they are used. Okay, so let's get started. So this is the story that we just mentioned. Okay. So in 1990 something, I can't remember exactly, but this person, they did a research with a lot of software companies, and they realized that the majority of the software companies, they are either using theory X or theory Y. So theory X means that they assume that people avoid work. Like they just wanted to get money, get a job, and they don't enjoy their work. So this is their assumption. And the managers try to control the progress, the performance, like the success, with some extrinsic incentives. For example, if you get all of your functions covered by test, I award you with like money or promotion or whatever. So there's some like extrinsic incentives. And they add a lot of measurements with like metrics, reports, documentations, and stuff. And with theory Y, the assumption is that people seek responsibility. Like they hope the project succeed, right? They aim for success. So what is in this, what is important here is like we provide them with the context, for example, learning environment, support, and then people work with autonomy and and giving them intrinsic motivation. See, well, see how many users are using what you have done, like are actually using your code. Well, Agile assumes theory Y, like assumes people having this kind of intrinsic motivation, or managers try to motivate the group, the members with intrinsic motivation, like everyone wants to succeed. So this is what Agile assumes. So metrics can be useful. This is why a lot of software companies, they use metrics. And metrics can give people feedback. Like for example, how many commits you have made. It's a way of demonstrating how much work you have done in some extent, like to some extent. Or other metrics like how many tests you have got. It can show how thorough your test to some extent. Other metrics may be how many lines of your code, how many lines of code you have wrote. So it shows something, but not everything, right? Yeah, cool. So it can be useful sometimes, but only if it's used carefully. For example, when the number becomes the goal, for example, if I say, I want every one of you write 100 of lines of code in next 2 days, right? Then what we got? Some lines of your code, some lines of code that's of not good quality, it's not working well, right? So, so the healthy use of this kind of metric is team use metric to inspect and improve their own work system. Right, for example, tests. You see whether the tests are cover all the functions to make sure that there's no functions that are not covered by tests, and there are some bugs in that function. Right, so this is like good intention or good use of metric. And management use them as a conversation starter, not a scoreboard. So you shouldn't use that as like, this is the goal for you to get promotion. But say, well, so as manager you can say, is there any function that's not covered by tests yet? Like as a starter of the conversation. And then you can have discussions with the team like, why that wasn't covered yet? Is it because like I give you too short time, like you need like more time to work on it because of time? Or is it because it's a blocker for you, you don't know how to add a proper test for that function? Or is it because you feel like that function doesn't need a proper test yet? Or what is it? So you can use that kind of metric as a starter of the conversation, but not the goal or like leaderboard or something. Okay, so now let's have a look at this example. So we were talking about test and coverage. So we use coverage reports as a concrete example of here, like helpful engineering feedback and a metric that's easy to use. This is very commonly misused by a lot of companies. Yeah, so coverage is a measure of how thorough our tests are. So now, since last week, we talked about tests. So how do you know whether you have enough tests or not? Or how do you know whether you need to add more tests for here or there? Like, how do you know that so far? Depends on the number of features. Can you expand that a little bit?
Well, the feature is more, it means we have more tests to cover it.
So if we have more features, we will need to have more tests to cover it?
Yeah, true.
Yeah, that's true. Yeah, so how do you know that if you need to have more tests for anything? So you may do it manually, right? You can check, you can have your test file here, have your implementation file here, and see, oh, this feature here, this function is covered by this test, or this test covered that function, right? But can we have some numbers or metrics that we can use? Like, for example, when we talk about pipeline, right, there are some tools that can help with automating a lot of things. When we use Git, it helps us with like collaborating with software projects, right? For like coverage of tests, is there a tool that can help us with the process so we don't need to do it manually, right? So it is called test coverage, and the other one is code coverage. So test coverage counts how much of the feature set is covered with tests. Like it's often manually, like human judge. Well, this is a feature about adding a task, and there's a test about like adding a task. So this is manual test, manual check, right? Well, code coverage can be computed and quantified with a number like percentage. It counts how much code is executed during test. So for example, let me see. This was the example that we used last week. So this was our backend, right? So you can see there are a few stories here, like displaying the tasks, adding tasks, and deleting tasks. And here's our test suite. So what we had was we tested the showing task, whether it shows properly. We also tested, what is it? Loads the task, shows initial task. Okay, so this was the test that we had from last week. And all of these are about showing tasks. So it's like from menu checking, we can see, well, adding and deleting tasks has not been checked with our test yet, right? So you know what something is missing. So this is called test coverage with human judgment, like see whether these features or stories are covered by a test. Well, code coverage is the focus of today. It measures as a percentage of statements or lines that are executed. So for example, here, so you can, because this code is pretty like short, pretty simple, so we can see what is tested here, what is run during this test. So we had, where is it? Response client get, app.lot, add task indexed, where's indexed? Client get assert response data. So those should be, oh sorry, here. Index load. Yeah, so those are the lines that are clearly not covered by our test. So when we run our test, so those lines or those statements are not covered by our test, right? So it's useful to highlight what did not execute. So let's use our project from last week as an example. So the tool that we can use is from PyTest. So last week we mentioned how to add a test, how to write tests using PyTest, right? But there's more that PyTest can do. So PyTest can also help with the code coverage, like how, which line of code in the app.py has been covered. And the way to install is by using pip install pytest-cov, that means coverage. But if you are using Mac system, that should be pip3. Right? So let's have a try. I'll copy this line from the slides. Open our terminal. Where's my terminal? Here's my terminal. Very messy, I'll clear it. Okay, copy and paste. I should be pip3 for me because I'm using Mac system. Okay, since I've already installed that before earlier, so it's pretty fast, but for you it may take a few seconds. And then what you can do is you can also add this pep test coverage to the requirements.txt. So that will be helpful, especially when you are using pipeline. Right? Remember that in the pipeline, the Git pipeline, you had like before script, you install everything from the requirement to make sure that the runner has all the packages installed, like everything required is installed in the runner. So it is highly recommended to add PyTest coverage to your requirement.txt as well, so that you can, like later you can add the coverage to your pipeline. And then run PyTest coverage, this one, I'll copy it, so that you can get a coverage report in the terminal. So I copied it, I cleared it again, so messy, I pass it, so you can see. Okay, perfect. So now you can see that this is an example of the coverage report. So you do not need to manually check the like test coverage or code coverage of your project. It helps you with that. So now you can see that the files that were checked are app.py, confess.py, test, and those test files. And for this one, there are a few statements, a few lines that are missing from the test. It means that when you run the test, those lines of code are not executed. So it means that your test did not cover those lines. So let's have a look at those. So those are lines 18 to 21. So 18 to 21. So those are the ones from the adding task roles, right? The other part was 25 to 27. 25 to 27 was about deleting, yet we didn't have any tests for deleting. Right, so it's very straightforward, very supportive, very powerful for us to get an understanding about the code coverage. And then we'll know, okay, I need to add a test here. I forgot to have that earlier, but I will need to have that. Why? Although we are not following TDD here. Like for TDD, we said we need to have tests first, and then writing the implementation later, right? In this case, although we already have the implementation, we should still adding the test back. The reason is because later on you may do some refactoring to your code. You may make some changes to your code, right? And when you make changes to your code, how do you know your changes to the code is not changing the behavior of the code? It's by the test. When all the tests pass, you know, okay, the behavior is still the same. It still works as intended. Right, so you should still add the text back. Okay, but you may say, well, although I have got this very powerful report, I want an even more convenient way of looking at this data. And yes, there's another way. I'll show you, see how powerful it is. I'll copy this one. So it helps you generate an HTML report. You can view that report through an HTML file. It's even more powerful. I'll just copy it. I'll clear and paste. Okay, so it tells you that coverage HTML written to the directory of HTML coverage, which is here. And this is a new folder just created with this command. So in this new folder, there is a file called index.html, and you can open it. The way you open it depends on the code editor that you use. But for me, I'm using Visual Code Studio, so I'll just open it here. You can see it's a better way to see this report, right? And you can also click on it. For example, you see, well, my major files coverage is pretty low, right? Only 58% means that almost half of my code was not covered by tests yet. So I can click on it and see more details here. Very helpful, right? So the green ones are the ones that were run during the test. Means that those lines of a code are already covered by your test. And those 8 lines that are in red are missing from your test. So you need to add text. Potentially not, maybe it's necessary, maybe it's not. Depends on your own like judgment. You do not need to aim for like 100%, right? It's very unnecessary. There may be just some lines of code that's not needed for any test. You will see that during your implementation. So this is why like we say sometimes it's not necessary to use metrics as the only goal, right? But the metrics can be very helpful. So this is the metric, right? Like 58%, the green lines, the red lines, this is metric. It's very helpful for you, right? If you use it properly. Cool, so you can also go back to index and have a look at the other files, right? It also tells you the total coverage is 79%. So let's have a look at these statements. So what's your understanding of statements? So what is this one? What does statements mean? So for example, let me write something here. For example, I have so let's have a look. Is this one statement? One statement or 1, 2, 3, 4, 5 statements? One statement. Yes. So one statement means one meaningful block of code. So you can have, for example, A equals 1. All right? So this is one statement. And this is also one statement. Or you may have, for example, you have, can I find another example? So you may have, you put here, you put them together, right? Is it one statement or two statements? Who thinks this is one statement? Who thinks this is one statement? Who thinks this is two statements? This is two statements. You are doing two different things here. Okay, so this is two statements. So this is how you can understand the coverage report from here. Other than files, this coverage report, you can also use like functions. You can have, for example, in this file, this function, there's no function, what is it? And some more obvious ones, for example, delete task is a function, right? And there are 3 statements in delete task function. And all these 3 statements are missing with text, has no text. Right? I love this HTML report, it's so powerful, so helpful. Any questions so far about how to get this coverage report from both terminal and the HTML file? Any question about getting the report? Or any question about using this report? Or understanding this report? Now think about how you can add this coverage report to your own project and how you are going to use the coverage report to improve your project. Now, do you have any question? All good? Okay. Yeah.
Set up a CI so that for every new features
Uh-huh.
should have a higher coverage, and then we can merge it to ensure all features stable and robust.
So you were saying that in the pipeline, add a coverage report for every feature. I don't think that's possible to add a coverage report for every feature. Oh, you mean for every branch or every feature? Every feature?
Because I think every feature should assign to everyone and have their own branch. It is their own module.
Great question. To be honest, I don't know how to do it. Like adding a coverage report for each feature. It may or may not be possible. So maybe you can do some research and see whether it's possible and let us know next lecture. We'd love to know that. Yeah, but as a minimum, what you can do is you can get a coverage report for the code on that specific branch. So normally what we do is having a branch for implementing a new feature. Right, so you can get the coverage report for that branch, and then you can get an idea of the coverage for that branch or that feature. Cool. Any other question? No? Yeah. Sorry, can you? What are the functions and classes at the top? Okay, so let's have a look at the function. I'll make it a little bit larger. So I think a good example is this delete and add task functions. So in files, you only have a list of all the files and all the statements and coverage together, right? So in this app file, there are a lot of different functions. For example, we had this add task function, we had this delete task function, right? So you may be interested in getting a coverage report for each function. Like for this function, it's pretty small, but sometimes you may have larger functions, or you may have a lot of functions. So you wanted to get an understanding about like, is there any specific functions that are missing from tests? Right, so what you can do is you can click on functions here. I'll make it a bit larger again. And then find the function, for example, this add task function in this app file. You can see that there are in total 4 statements, and 4 statements are missing from tests. Yep. Cool. Online, if you have any questions, feel free to let me know. I'm monitoring the chat as well. Okay, let's get back to here. You can get the instructions about how to get the coverage report from the slides. The only thing to note is that if you are using a Mac system, it should have a 3 here. Cool. Reading the coverage table, we've already talked about that. So here are definitions about statements, miss, cover, and missing. So if you forget anything, you can always go back to the slides and double check. Okay, the classic coverage mandate. So you may notice that some software startups or projects, they ask for like minimum 90% coverage. I'm not saying that it's wrong. It's just you need to use that metrics carefully so that people in the project, in the team, are not just aiming for the number, but aiming for a good coverage of the tests. Yeah, so cheap tests is not helpful but harmful. Cool. We've already talked about that. Yeah, so it's useful. One is used for like finding risky gaps that are missing from tests or guiding where to add text next. But it's risky when used as KPI or target or performance evaluation. Yeah, I think we've already talked about this, how to use it safely. Yeah, so this is a good thing, an important thing to know. So when you have some logic such as if, else, so it's very important that your test coverage all scenarios. So it's very common that when you write the test, you only cover one scenario when everything's happy, like the happy rods, right? When everything works well. However, there are many edge cases that you also need to consider. What if the user didn't use the product as it is designed? Right, for example, the example that we showed last week, when the user put in nothing in the block and then hit on add task, what should happen? Right, so that should be carefully considered as well. Although like when you design your software applications, you may have an intended way of people like how to use it, but users may not use it as you designed for it, right? People may use it like weirdly sometimes. So you also need to make sure that you have proper consideration of those edge cases with your test and also your implementation. So this is very important to note. Cool. Great. Yep, okay, so now the question, thanks for the feedback, through the feedback form. I have one student mentioned that AI is changing a lot these days, especially in the world of software engineering. You may also have heard the news from, like very sad news from Atlassian that they cut a lot of their employees last week. So I think it's very important that we know those trends. We learn about how AI can be helpful and sometimes can be harmful. So like use it properly. Yeah, so now in terms of AI coverage in practice, so AI can be helpful in a way that nowadays writing tests is much faster than the old days. And AI can also help you interpret your coverage report. For example, if there's anything that you're unsure from the coverage report, maybe you can check with AI. Yeah, but it's very harmful if you are like just using AI blindly with like tests, because in my previous course, I've seen students using AI to write a lot of cheap tests. And those tests only improves the coverage metrics. You are seeing the number growing, but it's not testing the project properly. And in the first few days or even weeks, everything should be okay. But when you are making more and more changes, adding more and more stories to it, like because your test is not testing properly your projects, and when you make changes and something's broken, your test is not working as it should be, like giving you like right notes or something, like in the long run, it will be more and more risky. Cool. Yep. It's becoming easier to create shallow, low-value tests just to move the number. So be mindful about the risk. However, like in terms of leadership, in terms of managers using metrics, so AI can be helpful. Like for some reports, for example, now you have those, while you are doing a project, you have those commit messages. Right, you have those messages for the merge request. So at the end of a sprint or at an iteration, normally the managers will need to write a report for like what we did this iteration or what we did this sprint. So here the AI can be helpful with the metric or the report with like summarizing the sprint by using all the commit messages. right? So AI can help you write a report directly. So less documentation writing for people, like they can write those metrics, those reports from the commit messages and the merge request messages. It can also like turn a list of what shipped it using those commit messages into a short narrative for the stakeholders, like in an easy to understand way for the stakeholders. So they spend less time like compiling reports for organizations. Cool. So what other ways do you think can AI be helpful for managers? So these are just things that I can think of, but you may have other ideas. Like AI is also new to me as well. So, so what do you think can be used in a healthy way, or what do you think can be pretty risky?
I think what AI help us is
Uh-huh.
that if you do not have some knowledge or
Uh-huh.
tech, or you can ask AI directly, not community with a senior.
Uh-huh.
But what is the risk is that someone will rely on, too depends on it, and they do not know the details they write,
Uh-huh.
so rely on AI, and trash in, trash out.
Yes, yes. So you mentioned that the good thing that AI can do is help you understand something if you don't understand. Like you can ask questions. But it can be risky when you use some AI generated code without really understanding it. And it can be very risky. That's a really good one. I was browsing Reddit, like some for the developer community, and people were saying the most regretful thing that they have done is merge in a few lines of AI generated code that they don't understand. It totally broke their product, which is very, very risky. So yeah, I think this is a lesson to learn as well. Like, do not merge in any AI generated code that you don't understand or fully understand. You need to really know what is it. Otherwise, it's so risky. Yeah, cool. So in a summary, AI will not remove the need for thoughtful tests. Like to write good quality, meaningful, useful tests, it still needs human to do it. AI cannot remove the need for that. It will reduce the cost of producing medical artifacts. For example, some metrics, reports, like AI can summarize the reports for you. The advantage is knowing how to use AI to strengthen good practices. Like you should know those good practices first, and you know how to do it first, and then can use AI to strengthen it. And avoid chasing like easy metrics just because AI makes it easy to produce. Cool, cool, cool. So that is our first lecture today about management and how to use metrics properly and what are the potential risks and harms of using metrics if they are not using properly. Do you prefer having a short break now and then we move on to the next part of the lecture, or do you prefer we just continue the next lecture, start the next lecture now? Take a break? Yeah, sure. So let's come back at 6:55. So 5 before 7. Sorry, yeah, 6:55. Yeah, 7 minutes break. Okay, cool, cool, cool. Okay, welcome back. Cool. So next topic for today, again, not very hard. So both of the topics today are pretty easy and not very challenging. So the second topic for today is about maintainability or refactoring or writing maintainable code. So why is this important? A few reasons. First of all, when we had our very first lecture in week 1, we mentioned that it's very common for software projects to change over time. And the change may come from different sources. For example, the user's need changed, right? Like they may ask for the features to be differently than originally they asked for, or they may ask for new features. So this is one source of change. Another source of change maybe come from the manager, like the direction of the project change, or the tech stack change, or maybe have new people joining the group, or people leaving the group, right? Or maybe you just wanted to change the code to be more elegant. Yeah, so there are a lot of different sources of change. So to make the change safe, there are a few things that we need to do, right? We need to have the project to be maintainable or being less risky to change. Have you seen something like this? I've seen a lot of different versions of this. The first stage is add a small function to perfectly working code, right? The code works perfectly originally. It's just a small function, but then everything completely breaks. And then you remove all your changes, code still broken. Right? I've seen a lot of different versions. So this is very common. Why this happens? It's just because making changes to the project requires the project to be maintainable, like less risky to change. How can we do that? So software changes over time. It's very, very common for it to change. And Agile teams ship in small increments, like they get feedback, they change, they get feedback, and they change. Changing is happening all the time. If your code is hard to change, you can't keep the pace for long, right? Like maybe you may rush to write some code, and it delivers some stories really quickly. But later on, when you add more stories, when you make more changes, you get slower and slower. But if you write maintainable code, you can implement new features without breaking the old ones. You can fix bugs faster. You can collaborate with merge requests with others because other people can read your code easily and easily extend your code. You can also work effectively with AI tools because AI also needs to work on your code, right? If your code is very messy, it makes it even harder for the AI to help you. And if you have maintainable code, it makes onboarding new teammates easier, including the future you. So you don't want your project to be like only last for 1 month or 2 months and then you throw it away, right? You want it to be used by actual users and getting better and better through the time and live forever, ideally, right? So you may go back to your own code. So how to help yourself, your future you onboard for your old projects. So sustainable means that like speed and speed in software is how quickly you can make a safe change, not just a change, right? Not how fast you tap as well. And maintainability keeps that speed as the code base grows. It's more important than raw performance. So at the beginning, you may like write really speedy and have some good performance, but it doesn't run for a long time. But how? The question more important here, like we know it is important to write maintainable code, like to be easier to make changes, right? But how? How do we do that? There are a few ways to help you to have more maintainable projects. The first is having tests. So having those tests, making sure that when you make some changes, you know whether it's still good or not, right? If there's some bugs, if there's something not working as originally intended, you can quickly fix it without having impact on the future or other parts of the code. So adding tests is very important for maintainability. We have already covered that. Another way to have maintainable project is by system design, by high-level system design. However, we cannot cover this in this course, but feel free to explore it later with your own time. Another way to have maintainability is through lower-level code design. So thinking about code as a high-level or low-level details in terms of what makes things resilient to adapt to inevitable changes in the future. So this is what we are going to talk about today. And we'll also talk about why this cannot be replaced by AI. AI can only help you with that, but cannot replace your role for writing maintainable code. So code design is something that happens between writing tests and writing code. So last week when we talked about TDD, we mentioned that we start with the test. And then we write just enough code to make that test passed. And the next step is refactoring that code to make the code maintainable. So that's the third step. And this is where the code design comes in. So it's when you know what solution needs to do, but needs to plan how it does it and make it maintainable. And there are 6 design questions to ask. So when you do your refactoring, when you have your test first, write the minimum, spend the minimum effort to make the test pass, and then you go back and then ask those 6 design questions to yourself. We'll go through them one by one today. The first one is there one source of truth for this? What does it mean? Let me show you an example. Where is it? Yeah, this is the one. Here. So here is an example. So you are implementing an online shopping system and you wanted to tell people how much in the shopping cart, how much does each item cost. So you need a price for each item, how much each for that item, and how many items the customer put into the shopping cart for that item, right? So for example, the first one for item 1, the price is 10, the quantity of that first item is 2, and the total price for first item is that. And then you tell the customer as well, item 1 total is this. And the user may add item 2, item 3, and later on may have item 4, 5, 6, 8, 9, 10, 11. Right? So this is the original code. What's the problem you see here? It's redundant, yes. So you may have endless blocks of code like this. Right? This is one thing. The other thing is, if something changed, for example, the way you calculate the the total price, or the print out message you want to show your customer change. For example, you don't want to say item 1 total, you want to say item 1 cost. And then you will also need to change item 2, costs. You need to change item 3 costs. Right? When you have a lot of blocks like this, it's very easily, you may have a typo here. I forgot to put S here. Or I forgot to have an O here. Or I had an extra O here. It's easy to make mistakes because you wanted to make the changes consistently. Right? And you need to change every time this message in your code. Right? Redundancy is one issue, but this kind of redundancy also brings in another problem, which is easier to make errors, having bugs. because you need to change every time it shows here. So this is where this first principle comes in. So when you repeat yourself, a change in that value or capability requires changes in all locations. And it's very easy to forget to change it in all locations or change it inconsistently in those locations. So try not to repeat yourself. To avoid this, we follow this principle called don't repeat yourself. Or you may see dry. So this is a commonly used principle in software project. It's called dry. When you see DIY, it means that don't repeat yourself. It focuses on reducing repetition in code. The same code should ideally not be written in multiple places. However, this is not that strict. We'll talk about that later. So every piece of knowledge must have a single unambiguous authoritative representation within the system. So repetition like this should be avoided, especially if you are going to have a lot of these. Like you may have 5 items, 6 items, 10, or even 20 items in the shopping cart. Then you need to make changes in many different places. Okay, so this is that example. The second principle or second question to ask yourself is this as simple as possible? Every line of code that we write needs to be maintained. So remember that. Try to have less lines of a code. Then you will have less things to maintain and less things to change in the future. For example, if there's an existing Python library or function that you can use directly, do you write your own? No, right? Like we can just call that function or use that library, right? So then you have much less lines of code to manage. Every line of code you don't write is bug-free. So that's the core message here. And this principle is called KISS. It's called KISS principle. It means keep it simple, stupid. Don't show people how clever you are. Oh, I can write this function, although Python already had that function, right? The idea is that software system works best when things are kept simple. It is the belief that complexity and errors are correlated, right? So clear code is much, much more important than clever code. No sane people likes clever code if it could be simpler. So let's have a look at this example. I'll just show it in the slides. Okay, this is the example. So what we wanted to do here is swiping to variables. Have a look at those 3 ways doing it. Which one do you prefer? A, B, or C? A? Anyone prefers A? Do you understand A? Yeah, takes some time, but yeah, understandable. Okay. Anyone prefers B? A few? Okay. Anyone prefers C? Okay. So for people prefers B, can you tell us why?
It looks like CPP.
Huh?
It looks to you like CPP grammar.
Oh, okay. Okay. Any other ones? Like any other source why you choose?
Yeah, because this works in many languages.
It works in many languages. Yeah. So no matter what.
If you do it in the third way, it's only support Python, and if you are using other
Yeah.
programming languages, it could be a problem. You have to write it in another way.
Yes.
It makes the code library bigger and maintain more code of those.
Yeah.
That could be a problem.
So it works the same for many different languages. For people who are used to C or JavaScript, it works for all of them. Very easy to understand, right? For people who choose C, why do you prefer C, the last one? Yep. Oh, sorry, what did you, the girl in the front? Did you say anything? No? Oh, you, sorry. What did you say? Less lines to maintain. Okay, what else?
Also like a very minimalistic way, and also like we are doing our project in Python, so
Because we are using Python for our project, so it makes sense to use the Python. Sorry, we are writing our project in Python, so it makes sense to use the Python way of doing things. Anything else? Any other thoughts? Very simple. Yeah. So both of these are okay. So, it mainly depends on your preference. Either one is pretty simple and easy to understand. So either one is okay, but try to avoid something like this. Right? It shows that you are very smart, you are very clever. However, it's harder to maintain, even for future yourself. Cool. So this is the second principle called KISS, K-I-S. It means that making things as simple, stupid as possible. The third question to ask is this over-designed or under-designed? Let's have a look at an example first. I'll show this in here. Where is it? Okay. So this is our example for this principle. So we have a login function, and there are two rows for this project. There are admin and there are moderator, and there are the only two rows for this specific software. And we want to send email to each of them when they log in as the specific row. So this is one way of doing it. And here's another way of handle login. When people log in as their specific row, and we send them the message, either like admin dashboard ready for admin or moderator panel ready for moderator. So which one do you prefer? Anyone prefers A? A few? Do you need more time? Any more people prefers A? Anyone prefers B? A few. Again, anyone prefers A? Anyone prefers B? Okay, so people who prefers A, why?
I think it looks more clearly and people can see it directly, know the structure.
The structure is clear.
Yeah.
Anything else?
It's more readable and you can tell that it's more clearly defined, so you can.
It's more readable and clearly defined. Yep. Do you have anything else to add? Okay. Only two rows are there, so is that what it? It doesn't have extra stuff. Maintaining could be easy.
And if the messages have more choices, it will either be a very long line or it will separate into several lines, and so it will be much shorter.
So what you said was if there are more rows, it will be a very long line here or even multiple lines here.
Yeah, so it will not look simpler than the first way.
Okay, so for people who prefers the second one, why? Less lines written, so less lines to maintain. Is that what you said?
Yeah.
Okay. Yep, anything else?
And it is expandable. Maybe in the future there will be more than just administrator and moderator, and it will be very easy to expand it.
It will be easier to expand in the future if there's more rows.
Yeah, and if you just write that message in
Uh-huh.
multiple lines, it'll be more easier to read too.
Okay, so yeah, so you can see that we have different opinions. So for people who choose the first one, do you want to convince the people who chose the second one? Or people who chose the second one, do you want to convince the people who chose the first one? Debating class. If you wanted to have more rows, you can just add more rows here. Okay. My preference is also the first one. Yeah. I understand why some of you chose the second one, because we just mentioned that we want to have less lines, right? We just mentioned that the lines, the less lines, the easier to maintain. We just mentioned that. But why are you here choosing the one that having more lines? This is because it's easier to read. Like the logic is much clearer. So this one is different from this one, where potentially we may have 10 or 20 items adding to the shopping cart. Well, this one, now we only have 2 rows. And maximum, we may have 1 or 2 more rows maximum. And you may want to send different emails to different people depending on the rows. That may be possible, like in the future you want to change. And another reason, as the girl in the front mentioned, that when you have a lot of different rows, you may have a very long line here, so it's harder to read. But as you can see, like different people have different opinion, and there's no single truth for this one, like which one is right or wrong. There's no like right or wrong answers here. It's just which one you feel more comfortable with. It also depends on the exact scenario, like whether you will be adding a lot of different other rows, or whether you are pretty sure, well, there's just 2 rows. It depends on the scenario. Cool. This is the over-designed or under-designed. So it's very common that we start from under-designed, like examples like this one. This is a very obvious under-designed. And then gradually we becoming smarter and smarter, do some like design like this or design like that. But gradually we'll find a balance that's right for us or right for you. Okay, take some time to practice. Okay, the next one. Are related modules kept close together? Are unrelated modules kept far apart? What does that mean? So let me show you an example. This example. Okay, so we are using the task tracker as an example. So this is the first way of doing things. This is the second way of doing things. So what we are doing here, so for the first way, like we have a definition called add task, and we add task. And then we have another function called delete task, we delete task. We have another function called about display task, and we format the task list and display the task. 3 different functions. Well, another way is we can have one function can do everything. We can, the action can be add, the action can be delete, and no matter what action is triggered, we display the tasks. What do you think of the 2 different ways of writing these functions or writing these features? So the reason that I'm showing this example, because what we want ideally is we want related components to be tightly coupled and unrelated components to be loosely coupled. So what does coupling mean? It means how much one piece of code relies on another piece of code. Why is this important? because we are talking about maintaining code, we are talking about changing code, right? So if you have functions that depending on each other like this, and if you change one of them, it's very likely your change to one of them will have an impact on the other parts of your project, like on other functions, right? But if you have like two functions or two things that are like separate, and you change one of them, it will not have impact on the other one, right? So coupling means how much one piece of code relies on another piece of code. If your project getting bigger and bigger, so now in Sprint 2 it should be okay, but when you move on to Sprint 3 and you are collaborating together with more and more features, stories, or more complex ones, you will notice that your work will depend on each other's work. So for example, group member A will be saying like, oh, I'm waiting for member B to finish his work so that I can start mine. Or my change will have an impact on group member C's like features or whatever. It's very, very common to happen. So you want to have them, like if they are not that related to each other, you want to separate them. But if they are just by nature related to each other, you can just keep them together, no problem. Cool. So extensive coupling can also lead to spaghetti code. Spaghetti code means like code like this, like everything connected to each other. So can anyone tell me why the second way is spaghetti? Like why the second one can be messy, can be problematic? Yeah, so these two functions can be independent, right? Like add task and delete task and display task can be independent. But now if we put them all together, like you are putting something can be unrelated together. But why is it problematic? Why do you put like the actions with displacing tasks being problematic?
Maintain the old feature, we need to search in this large like one by one to
yeah, exactly.
If we divide into different modules, it's very easy to search them.
Yeah. So it's much harder to maintain because everything's mixed together, right? Harder to read as well. And printing logic is also very different with the action logics. So adding tasks, deleting tasks, they are like logics about actions that the user trigger. However, like how you are going to formatting the task can be very different. And now you are putting everything together. It can be problematic. Cool. Okay, the last question to ask, this is a very, very, very common mistakes that beginner programmers make. Like, am I speculating about how necessary this is? We briefly touched about this last week in the testing lecture. We mentioned that we only write enough code to make the test pass, right, at the beginning. So this means that are we thinking, well, this line of code may be useful in the future, and then we write that line of code? Or am I like, I think this helper function can be very helpful. Like, although for now I only need this helper function once, but I'm really sure that this helper function will be used again, again. So I separate this part of my code as a helper function. So I'm speculating about the future. So that helper function may not be helpful in the future. You are thinking about the future. So only if you really see the need for the helper function or for that line of code or for that blocks of code, you write that blocks of code. Otherwise, just keep things simple. And this principle is called Yagami. it means that you aren't gonna need it, like YAGNI. Okay, this helps remove unnecessary code and therefore results in having less to maintain. Here's an example question. Should we add export to PDF for the task tracker task links before anyone has asked for it? No, right? So all the stories should be from the requirement engineering that you had in the sprint 1, right? Like when you interview people, when you do the market research, when you did the observations, you got those stories, right? So if during that stories generating process, you notice, well, this is highly needed, like export to PDF, and people were asking for it, then yes, if this is prioritized in your stories, and you can have this feature. But if no one has ever asked for it, do you need to have it? No. You may just having some redundancy in redundant features in your project. Oh, we have one more. Okay. Does this follow standard conventions? Okay, this is a very good question. Will you be writing a web application using C programming language? No. No. Why? Huh? Yes, you can do it. Like, it's your choice to do. Yeah.
How to judge the efficiency? Like when I'm using C, I can control the stack, also some loops myself instead of like using libraries. So that is more efficient.
Yeah. You're saying, like, for example, using C to write a web application is more efficient. Like, I'm not saying you can't use C to write a web application. Yes, you can. However, this is not following the standard convention. Like, the more popular the approach is, the more likely there are resources that you can use and make things easier to maintain, like from the maintainability perspective. Like if you have libraries, framework to use, but for example, if you're using Python or JavaScript. But if you're using C, you'll notice that very few, maybe there are people using C, but very few people are using C. It means that there are much less resources and support you can get. And there may be a reason that why people are not using C. Right? It's possible to use C to write a web application, but it's harder to maintain because it's not following how people are normally doing it. And in the future, when people wanted to contribute to your web application, they may have no experience using C to write a web application. But most people will have experience using like Python or JavaScript. So like no single person can write a big industry-sized software project. It needs to be a teamwork. It needs to be a group work. You need to work with people. Even though like any genius cannot write on YouTube, right? They can write something like YouTube, but they cannot write the size of YouTube. It needs to be a group of people. So if you follow the standard convention, it's easier to maintain not just for you, but for other people who are contributing to the project. Cool. So similarly, other examples like uppercase constant or to library choices, for example, Flask is very popular, a lot of resources for it, people are easy to contribute to it. Cool. Yeah. This is the one that I mentioned, having a helper function which is unnecessary. So refactoring, what does refactoring mean? So we mentioned that following the TTD process, we start with testing, just enough code to make the test pass, and then refactoring. Right? Refactoring is the process of restructuring existing code without changing its intended behavior. So from the black box perspective, it's like you are changing things in that black box, but from outside that black box, things still behave in the same way. Like after you refactor your code, it may be faster, maybe easier to maintain, easier to change, but it just within that black box. But from outside, it's still the same behavior. Typically, this is to fix poor design in existing code to make things more maintainable. Yeah, and refactoring is strongly discouraged if you don't have a strong test suite. So refactoring only happens when you have a strong testing suite. So you know that your changes is not breaking the project. So you know things are still working. Okay, now the question, why does it still matter with AI? I'll not show you the slides. Tell me your thinking. Do you think like AI can be helpful for refactoring, or do you think AI still have limitations for refactoring?
I think it depends.
It depends.
Yeah, it depends the complexity of your project, and it depends the user. Yeah, because you need to have the architecture in your brains and you put it to AI, and AI will know that. You cannot just tell AI, hey, help me to refactor this. That's not.
Yeah, so you can't just tell AI refactor this, right? You need to have a higher level of understanding what and how to refactor. Yeah. Any other thoughts? AI can make mistakes. Yep. Yeah, nobody's responsible for it. Like the one who click on merging, and those two people are responsible. Yeah. Yeah. Any other thoughts?
I think it's probably one of the things it's better at when it comes to programming, because there's already a base for it to refer to when refactoring something. So it does have a bit more context, which is why I think it's a little more useful for purposes like refactoring, or just maybe repurposing your code into something else.
So AI can, to some extent, help with refactoring because it knows the principles. Is that what you mean?
No.
No.
For example, let's say you're trying to maybe, I mean, this is something our group did. We were trying to remove some JavaScript elements and then, use them in Flask instead. So, in a case like that, you probably could use it because the core principle would be the same. You know what it has to do. And that implementation already exists in JavaScript. So if you have to apply it to another language,
yeah. Okay. So just to summarize for people online. So what you just mentioned is that, for example, you may have a project that was originally the backend written in JavaScript and using the JavaScript framework for the backend. And later on, you want to change the JavaScript project into Python using Flask framework. And then you are just refactoring it from one language to another language. Well, the behaviors, the logic still stays the same. So in that case, AI can be helpful. Yeah, that's a very good thought actually. I haven't thought about that before, like moving from one language to the other. Is there any risk in doing that, like changing the whole project from one language to the other one, relying on AI? Yes. Yeah, I thought so too. Yeah, because as we mentioned earlier, we shouldn't merge in any line of code that we are not fully understand. But changing the whole project from one programming to another language, there will be a lot of code for you to review. Like the workload of reviewing the AI generated code is also huge. Yeah. Cool. So here's what I have got. So AI suggests ideas based on your code base. So if your code base is very spaghetti, messy, or duplicated, so it makes, the AI will make even messier refactoring if your original code base is messy and not following the proper principles. So you need to have a clear structure from human at the beginning, so that makes both human and AI changes safer in the later. And then we mentioned this a few times already, like you still need to read and approve every change, right? So you need to know those good principles of maintainable code. So when you review those and approve those changes, you know, well, this is good or that is not good. So you need to know those principles, and you need to know what is good and what is wrong. And AI only implements what you asked for. It doesn't decide what should be simple or flexible. So it cannot make that decision for you. Like the design decisions should be still from humans. So, yeah. You decide what better means. Like humans should still make the decision. Bottom line, AI can write and change code. It doesn't replace the need for good design. Maintainability is what keeps the code base a place where both human and AI can work efficiently or effectively together. Okay, cool. So that's all the contents for today. So after this lecture, what you can do for your project is starting to refactor your project code. Ask those 7 questions. Looking at code, asking a question, am I following the drive principle, the key principle, the Yagi principle? Am I duplicating myself? Am I over-designed or under-designed? Asking those questions to yourself. But before refactoring any line of code, making sure that you have a strong test suite before you refactoring anything. Okay, any question about refactoring? Or maintainable code? Oh, good. There's a question online from Abhinavi Pradeep. I don't know how to pronounce that. Sorry about that. So the question is, when can we expect the marks for Sprint 1, please? It's already released to you on Moodle. I'm just drafting the newsletter and making the announcement. I'll put a link in the newsletter. But if you go to Moodle, go to the grades tab, you should be able to see your Sprint 1 marks. But the feedback, I think some tutors give pretty detailed feedback, but some are pretty abstract. But anyway, during your class today, this week, during this week's class, your tutor will explain the feedback to you. So if you have any concern with the mark, any question about the feedback, make sure that you ask your tutor during your class this week. Okay, any other question? Yeah, I believe Sprint 1 marks is really high. The average mark for Sprint 1 was above HD. So the average mark is above HD, very high marks for Sprint 1. Well done, everyone. Congratulations. Yay. Very well done. For Sprint 2, you will notice that the marking matrix, the rubrics is becoming more challenging. For Sprint 2, more work to do, higher quality required, so it will be less easier to get HD comparing with Sprint 1. Yeah, so more work is required, and Sprint 3 will be even more challenging than Sprint 2. So make sure that you build a strong foundation, like we are still building foundation, all the way to Sprint 3. So for example, Sprint 2, we are using what we have learned in both Sprint 2 and Sprint 1, right? Sprint 3 will be the same. Like you will be applying all the concept and knowledge you learned. Okay? Cool. Any other questions? Nope? Okay, cool. Thank you so much, everyone. 20 minutes back to everyone. Yay, I love it. Okay, cool. Thank you. See you next week. Thank you.